This part we did not discuss last time. I ran out of time. Okay, so this function we know how to graph. This is the base function, the square root of x, and moved 3 to the right. So that's no problem, the square root of x minus 3. Now, can anyone identify this point for us? Comma. Perfect. And let's say, can anyone identify this point? 4 comma? Yes, excellent. 4 comma 1. So at least I have 2 points, right? On this graph. Okay, now I would like you to give me 2 points that I will use to graph the inverse function. So this was the function. So this was f of x equal to the square root of x minus 3. And now I want to ask you, and I will wait for you to determine or give me 2 points so that I can graph the inverse function. Exactly. Why 0, 3? Because that's the property of the inverse function, right? So if the function takes 3 to 0, what will the inverse function do? Will take, okay, the function takes 3 to 0. The inverse function will take 0 back to 3. It's carved in stone. We know that. So this point was for the function 3 comma 0. The reverse order 0 comma 3 must be a point on the inverse function. No questions asked. Is that clear? If this point is 4 comma 1 on the original function, which point will you plot? 1 comma 4 indeed. So this is the inverse function, which is x squared plus 3. And as you noticed already, the fact that we are reversing the coordinates of the points to determine the graph. See what happens? The 2 graphs will always be symmetric with respect to, what is this? We know this because we graphed it first when we looked at transformations. What was it? Y equals? That's it. So this is our note. Very important note to remember. The graphs of f and f inverse are always, I'm missing a word and I'll wait for you, with respect to the line y equals x, which is, you've said it. Very good. Indeed. They will always be symmetric with respect to the line y equals x. Why does that happen? It's because this point goes across, this point goes across, and this distance has to be the same. Of course, on my graph is not perfect, but that is always the case. Okay, I'm ready, Heather, for your questions.
It's in my
Let me,
shorthand note.
just 1 second, let me build my tens here. Yes, I'm ready.
So I'm trying to remember exactly. I know it asked for the domain, and I think it asked. I don't know what else it asked.
Yeah, just give me the functions and the.
It was. Oh, f of x is equals the square root of x. G of x equals x plus 2.
And we want to determine the function composition for which one? For both or for?
Of g.
So we want to determine the domain of f cum g.
Mm-hmm.
Good. This is just a domain.
Yes.
We're not interested in the function, and we will never find the function first, ever, when we determine the function, the domain of the function composition. We have to find the domain first. Okay, since it's f cum g, which function do we apply first? Of course. G, of course. So x is first. We apply g, and we get g of x. And then we apply f to get f of g of x. Agreed with this step? Yes? Okay, great. So the first set represents what for g?
The domain.
Excellent. Great job. So can anyone give us the domain of g? Look at g, identify what it is, and give me the domain. Say it again. There is no domain of x plus 2. Right. It's a polynomial function. It's a linear function. It will be defined everywhere. You can plug in x whatever you want. Great job. Okay, so now let's talk about the second set. What does the second set represent for g? Very good. So now I want to define the range of g. So imagine that graph. You know how to graph x plus 2. It's already in your mind. We have graphed several of them. What will be the range of this function? Alex, go ahead. Of course, of course. A linear function. Excellent. Perfect. However, this set is also what for f? Very good. This is also the domain of f. Look at the function, which is f. We graph them several times. We graph that function several times. We know its domain by heart. We don't have to even write anything now. What is its domain? Picture the graph with your mind's eyes and say domain is very good, of course, 0 to infinity. Okay, we have a problem. Here's why we have a problem. Because g is applied to some numbers here that will return negative numbers. Potentially, right? But I cannot apply f to negative numbers. I can only apply f to positive numbers. Which means I have to ensure that g will never be a negative number. How do I do that? What is g equal to? G equals what? How much? How much is g? Very good. So x plus 2 less than 0 will mean x less than negative 2. Would you agree? So if g brings here any number that is less than or equal to negative 2, f cannot be applied to that number, right? So if I pick x that is less than or equal to negative 2, the answer will be a negative number less than 0, and then f cannot be applied to it, which means from the domain of g, which is negative infinity, we must exclude negative infinity to negative 2. So why? One more time. Because if I apply g to numbers between negative infinity to negative 2, the answer will be negative. And then f cannot be applied to that number. So then the domain of the function composition must be negative 2 to infinity. And this is the domain of f comma g. Does it make sense?
It's not intuitive, but yeah.
It's not intuitive. No, it's not. So first, I realized that g will bring almost everything, right? I mean, everything, negative infinity to infinity. But then I'll have a problem if this number happens to be negative 5, because the square root of negative 5 is not a real number. So I have to exclude any possibility that g will bring 0 or less. 0 is fine, less than 0. So then x plus 2 less than 0 gives us x less than negative 2. All these numbers have to be excluded from the original domain. Once I say that this is not the domain anymore, but the domain is only negative 2 to infinity, when I apply g to any number here, it's guaranteed that for the answer to be 0 to infinity. And now the chain will not be broken because f can be applied to 0 to infinity. I don't think that this topic is part of this class. For that reason, I will not test you on it. But you will see problems in my math lab. Do you have another one for us?
No, I think that's the only.
Okay, so it was probably one, maybe two. Okay, any questions on this problem? Please remind me, I believe we looked at this problem, but maybe not. Have we looked at this problem? No, okay, that's our next step then. And here is another, just want to erase. Every class is different, every class wants a different problem, so I'm going to ask you to choose another problem in a second. I just want to get my pencil ready. Okay, ready? So let's read this. The graph represents the probability of two people in the same room. This is a famous statistics probability problem. Sharing a birthday as a function of the number of people in the room. So let's read this graph. First of all, is this function one-to-one?
Yeah.
Oh, yes, yes,
By
yes,
the-
yes, horizontal.
By the horizontal line test, this function is one-to-one. So according to the model, if we have 4 people in this room, the probability is 85% that 2 of us will share the same birthday, not the year, but the month and day.
September.
So if we have 50 people in the room, the probability that 2 of us share the same birthday is 95%. However, so my question now is, since it's one-to-one, does it have an inverse function?
Yes.
Yes, because it's one-to-one. Very good. So here's the question that we are asked to answer. Describe in practical terms the meaning of f inverse of 0.25, f inverse of 0.5, and f inverse of 0.7, which means we are looking at the problem totally differently, the opposite way. This is 0.25%, and the answer will be f inverse of 0.25 will be roughly 15. So how many people, in other words, we have to have in the room to have a probability of 25% that 2 of us will share the same birthday? What do you think about f inverse of 0.5? What would you say about that?
20.
So you will say the probability now is 50%. And how many people should we have in the room? Roughly 24, 25. The last one, so these are the applications of inverse functions. So the last one says, right, how many people should we have in the room to ensure a probability of 70%, assuming the model is correct? So roughly, I will say 30. Any questions? Okay, another question here. I would like to look at these graphs. Please choose one, whichever you prefer, so we can draw the inverse function. 35, 36, 37, 38. And then I'll tell you which one was chosen by the other class.
36.
36. Okay, perfect. Is this function one-to-one?
Yes.
By the
Horizontal line.
horizontal line test. I need you to give me several points so I can graph it. What am I graphing here?
Y equals X.
Very good, y equals x. So please give me several points. So you said 0, -3. Awesome. Next one. So it's 2, -1. So this is -1, 2. So we want 2, -1. It has to be a cross right here. Good. And this point where y equals x crosses the original function, the f function, must be part of the inverse. Why? Because on y equals x, I have 1, 1, 2, 2, 3, 3, 4, 4, reverse 3, 3. Still 3, 3. So any point that where the function crosses y equals x must be part of the inverse as well. Mandatory, because this point has the same x and the same y. If you reverse 3, 3, you still get 3, 3. So this is function f, and this is function f inverse. And now I would like us to answer whatever you want from here. So we see how tables work. So choose whatever you like. So you have the 57 and 58. They have F inverse functions, and the others have function composition. So you choose what you like to see. Yes? Okay, I'll choose. Okay, so let's say F inverse of G of 1. So what do I have to find first? G of 1, here's G, here's 1, how much? 1. Now I want to find F inverse of 1. I go to F, I look at where F of x is 1, because F inverse will be applied to the y value and will return the x value. So what is the answer? -1. Okay, one more. Let's say G comp F of -1. What do I have to determine first? F of?
-1.
Excellent. F of -1. How much is F of -1? 1. And then I have to find G of 1. G of 1 is 1. So I'm hoping that you'll see these problems in MyMathLab and you'll have 0 difficulties. The last section of this chapter, 2.8, deals with 3 different things. Yes, any questions, please? Oops, sorry. Any questions, please? Yes, which one?
Inverse function.
Yes. Which one?
F of x equals x plus 8 over x minus 2.
Yes. So, which problem is that?
Oh, it was one that was.
That's okay. Never mind. So, MyMathLab. Okay. F of x equals
X plus 8.
x plus 8 over everything over 2.
X over 2. Or x minus 2. I'm sorry.
In the denominator, like this.
Mm-hmm.
Excellent. So we immediately state that x cannot be
2.
Excellent. Good. Is this 1-to-1? Well, it is. We are going to graph it in section 3.6. So you have to, for now, you have to trust me that this is 1-to-1. Good. Step 1.
Change f of x to
Very good. Y equals x plus 8 over x minus 2. Number 2.
swap x and y.
Yes. Oops. X equals y plus 8 over y minus 2. Don't write that. I'm going to erase it right now. Good. And step 3, what do we do?
Swap the y.
Excellent.
Okay, I got 100.
Excellent. So here's my hint to you. What do we do? This is A. How is it called? I won't know. It's been a while. I'm begging you to redo your tests every weekend. If you want to be solid and prepared for the final exam, I will set aside time. You have solutions. You have the blank tests. I will redo those tests every weekend between now till the final exam. And you will have 0 difficulties with the final exam. If you don't do that, I can predict. You may still be able to do very well. So what does this mean? What is this? Anyone remembers? How is it called? Say it again. Cross multiply. Very good. It's a proportion. Excellent. So then 1 times y plus 8 equals x times y minus 2. Now what? Can anyone help? Very good. Well, y plus 8 equals xy minus 2x. Next. I can't. They are separated. They are all over the place. So I have to move this next to y, and I have to move this next to the other one without y. So then y minus xy equals -2x minus 8. Remember, I'm solving for y. Y is the variable in the problem. So what should I do?
Oh, you just took it away.
I cannot distribute y. There is nothing to distribute. But you're talking about factor. Exactly. Awesome. 1 minus x equals negative 2x minus 8. So obviously y equals negative 2x minus 8 over 1 minus x. That's our F inverse, but I would like to clean it up a little bit. So from here, if I factor out negative 1 at the top, and I factor a negative 1 in the denominator, I rearrange it much nicer. So F inverse equals 2x plus 8 over x minus 1. Of course, I have to write x not equal. Careful. X not equal 1. And that's it. My math lab will probably not ask you to write the domain, but I have to. It's mandatory. Any questions? Very good problem, Heather. I appreciate it. You are helping me when you ask questions because there is no way I can present everything here. Yes, go ahead, Michaela, go ahead. Any questions here? Is there anything else that you encountered in my math lab or anything else that you would like to go back to? Anything else before we look at the last section of this chapter? Heather, anything else?
No.
Okay, so 2.8, we're going to look at 3 different things. Distance formula, midpoint, and circles. Distance formula, the midpoint, and circles. Okay, so let's start with 2 points on the coordinate system. I'm going to call this point A and I'm going to call this point B. And let's say we want to determine the distance between these 2 points. I'm going to give A and B some coordinates. I'm going to say x1, comma y1 and x2, comma y2. I'm going to form a right triangle. And I'm going to use, since this is D between A and B, I'm going to use the Pythagorean theorem. But we have to identify the measure of the legs first. So obviously this is x1, obviously this is x2, obviously this is y1, and this is y2. Can anyone identify the length? That is the length of this leg and also the length of that leg. Can anyone give us the answer? If this is x1 and this is x2, how much is this? x2 minus x1. Very good. No problem there. If this is y2 and this is y1, how much is this length? What do you think? So if this is y2 and this is y1, how much is this? Say it again. Yes. You're challenging my hearing. Good. So therefore, by the Pythagorean theorem, d squared equals x2 minus x1 squared plus y2 minus y1 squared. Do we agree with this? The Pythagorean theorem. The hypotenuse squared equals the sum of the squares of the measures of the legs. We will take the square root from both sides. What do we always write when we take square roots from both sides? Always. What do we write? Exactly. In this particular case, it's a distance. I will have to omit that and just write x2 minus x1 squared plus y2 minus y1 squared. Now let's analyze this definition. So this is the distance formula. Can we further simplify it? Please say no. No, because the square root of a sum cannot be simplified. This is it. So what type of number will always this quantity always be? What type of number? It's a quantity squared. What type of number can that be? Excellent. What about this one? Positive. We are adding two positive numbers. Will I ever see this on your tests? No. Just making sure. Okay, so the midpoint. What is the midpoint? Let me put it on the graph here. The midpoint is the point that we say bisects, divides the line segment into two equal pieces. So that's the midpoint. So this piece equals this piece. And the coordinates, we can prove those too, but the coordinates are very easy to determine. Coordinates of the midpoint, it's the sum, it's the average of x's. Sum divided by 2, and the average of y's, their sum divided by 2. Before we move on to the circle, I would like to practice. Please give us two ordered pairs, any two ordered pairs you'd like, but they should have at least one negative in there so we see how it works. Very good. Negative 6 and 2 is perfect. And the other one? 23.
I'm not sure 2 and 3.
Oh, 2 and 3, okay. That's good. 23 is good too. Excellent. So let's start with the midpoint because that's the easiest of the two. So let's please add up the x values and tell me what you get. Negative 4 divided by 2 is? That's it. That's the x coordinate of the midpoint. And now please add up the y values. No. So it is 5 halves because 2 plus 3 is 5 divided by 2. Well, now I have to give you that. If I say 9 minus 49 is negative 42, now you are allowed to say that 2 plus 3 is 6. Okay, good. So now let's do the same thing with the distance. We write the formula. x2 minus x1 squared plus y2 minus y1 squared. I recommend, like I did with the equation of the line, I recommend name them x1, y1, x2, y2, and write them under the formula before you do anything else. So I have 2 and negative 6, and I have 3 and 2. So then, let's do this together. How much is 2 minus 6? 8. How much is 8 squared? Very good. Plus, how much is 3 minus 1? I'm sorry. How much is 3 minus 2? 1. How much is 1 squared? Very good. So then the distance is the square root of 65. Remember, you cannot separate a radical if there is a sum underneath. Okay, finally, let's look at the circle. It took us, like what, a month and a half to finish one chapter. I'm slow, I know.
No, you're a bit fast.
So here it is. I claim I graphed a circle, and you'll say not really, and I will have to agree. The center of the circle by convention is denoted by C, and the x coordinate is denoted by H and the y coordinate by K. Of course, this distance between these 2 points, center and any point on the circle, is the radius. And I'm going to denote this point anywhere you wanted it to be, doesn't matter, by A, and it has an x and a y. It's a point on the circle. Okay, would you agree if I say that the distance AC is exactly the radius? Would you agree? It is, right. Very good. So now I would like us to use the distance formula with x minus h, everything squared, plus y minus k, everything squared. So this side is the square root of x2 minus x1, which is x minus h, everything squared, plus y2 minus y1, which is y minus k, everything squared. This is the equation of a circle. By the way, is the circle a function?
Yeah. Yeah.
No.
By the
Nice.
vertical line test, it's not a function. It's actually two functions. It's this function and this function. Okay, so now we will square both sides. The left-hand side is x minus h, everything squared, plus y minus k, everything squared. And the right-hand side is, that's it. This is the equation of a circle with, no, because we prefer this, but you can consider that too, yes. The equation of a circle with center h comma k and radius r. Yes.
Thank you.
So this is the equation of a circle with a center C, coordinates h comma k, and radius r. There are three types of problems here that we will look at. Three types. Concerning the circle. Here's the first one. Given C of coordinates negative 2 comma 4 and radius 3, write the equation of the circle. Remember the equation of the circle, we should always write it. X minus h everything squared plus y minus k everything squared equals the radius squared. So now replace what you need to replace and give me the equation, please. X,
Let's say
I'm sorry?
let's say R next to equals 3 at the top.
Yes, yes. So x, very good, awesome, plus, very good, awesome, excellent. This is the equation of the circle with center negative 2 comma 4. Notice that the formula has a negative if one or the other or both coordinates of the center are negative, then this changes into positive. This one was positive, it stayed negative. Let's suppose we're asked to graph. Here's how we graph the equation of a circle or a circle. I start with the center, which is at negative 2, 1, 2, 3, 4, right here. The radius is 3. We will plot 4 points. One west, 3 units away, the other one east, 3 units away, the other one north, 3 units away from the center, and the other one south, 3 units away. Ready? So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Here's the circle. So this is a circle centered at negative 2 comma 4 and the radius with a radius of 3. Here's a second type of problem. X minus 3 squared plus y plus 2 squared equals 1. We're given an equation, and this time we're asked find C and R. Can anyone tell us what C is? And how much is R? Yes, of course, R is 1. Great job. Very good. 3 comma negative 2. Do we all understand this?
Yes.
Any questions?
Keep going a little bit. I'm still copying.
Is this okay, everyone? Yes? Okay, here's the last one. Of course, the last one is the most difficult one. I'm going to copy problem 58 on page 332. X squared plus y squared plus 12x minus 6y minus 4 equals 0. The question here is, does this represent a circle? Is this a circle? Is this a circle? Well, I have no clue. Maybe. If I manage to present it like this, then yes. If I can't rearrange it like this, then no. A long time ago, it seems like it, we looked at solving quadratic equations using 4 different methods. And I said, there's one that is important, but not for solving quadratic equations, because it alone cannot do the job. But it's a very important method for something else. This is the something else. Which method was I talking about? Right, exactly. Complete the square is not useful when it comes to solving quadratic equations, but it is the only way here. Completing the square. Good. So we have how many squares to complete? 2. One with, and one with, of course. They are completely separate. See, there is no x, y together. This is only with x and a number. This is only with y and a number. All right, very good. So let's look at and start with x. Middle coefficient divided by 2 and square the number. The middle coefficient is
12.
divided by 2. Square.
36.
Excellent. So plus 36 plus 36. Remember, we cannot just add to one side and forget about the other. So therefore, these 3 are here now. What's in there? Yes? Indeed. Indeed. It's what we squared to get 36. Excellent. I have to have plus. Now let's focus on y. Middle coefficient. Divided by 2. Square that number. That's it. We have to add 9 to both sides. Now these 3 are here. Oh, well, what's in there? Yes? Y minus 3 indeed. Great job. Let's see what is left. We have 3 things left here. We have this, we have this, and we have this. So of course negative 4 must make its way to the other side. So I have a 4 now on the right, a 9, and a 36. How much is that?
49.
Indeed. And now I'll say yes. Yes. I was able to rearrange that equation into the specific equation that is the equation of a circle. Now I can identify the center and the radius. What is the center and what is the radius? Negative 6, 3. Very good. Awesome. And that's it. See how easy this is now? Because we practiced. Yes?
Wait, how do you get,
Jordan?
how do you find the radius?
I took the square root from 49. So see how easy this is? Because we've seen it a long time ago. So it's useful to present it, but it's not useful to apply it in solving quadratic equations. We know that. Okay, do you feel like practicing another one?
Yes.
Very good. Would you like to choose, or do you want me to choose? 60. So x squared plus y squared minus 6y minus 7 equals 0. The same question. Is this the equation of a circle? And the answer is I have no clue. Potentially, maybe, I don't know. If I can arrange it like this, yes. If I can't arrange it like this, or the right-hand side is 0 or -5, then no, it's not a circle. Okay, it appears that x squared is by itself. There's no other x in there. So this piece is just x squared, or x minus 0. Everything's squared, so that's done. Nice. So now I have to focus on y squared and -6y. Middle coefficient. Divide that by 2. Yes, square that -3. That's it. Great job. So now these three are here. And then, of course, I have to move -7 to the other side. So what do I have in here? Of course. And what do I have on the right-hand side?
16.
Excellent. So now this is a circle, definitely, with a center blah, 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 and the radius blah, blah, blah. I'm ready when you are ready. 0, 3, and the radius of 4. Very good, awesome. Any questions on this circle? Would you like us to graph this one, the last one? Yes, let's graph one more. So 0, 3, 1, 2, 3, and the radius is 4, so we need 4 points, 4 distance of 4 south, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And here's the circle with center 0, 3 and radius 4. Any questions?